Hello and welcome to yet another video of Cornerstones of Math. In this video, we intend to find all real numbers x and y satisfying the system of equations y times e to the power of x squared equals 3e squared and y to the power of x squared equals 9. Just in case, I remind you the rule for multiple exponentiation, and let's get right on to it. The first method is what I would like to call sum and product method, or quadratic equation method. The equations contain some exponents, so let us take natural logarithms on both sides of equations 1 and 2. From the first equation, it is easy to notice that we obtain x squared plus ln y equals 2 plus ln 3, and from the second equation, x squared times ln y equals ln 9. When doing so, the only concern here is when y is negative or 0, because then we cannot use the expression like ln y. However, if y is negative or 0, there is no way that equation 1 can be satisfied, because the right-hand side would be positive and the left-hand side would be non-positive. So we know that y must be positive, hence we can take logarithms like this. Here, the sum and the product of x squared and ln y are given. This is equivalent to the problem where the sum alpha plus beta and the product alpha beta are given, and we have to find the values of alpha and beta. Here, alpha and beta are roots of the quadratic equation t squared minus alpha plus beta times t plus alpha beta equals 0, because this equation can be factored into t minus alpha times t minus beta equals 0. In our problem, the sum of x squared and ln y is 2 plus ln 3, and the product of these two is ln 9. Therefore, we know that x squared and ln y are roots of the quadratic equation t squared minus 2 plus ln 3t plus ln 9 equals 0. Here, this ln 9 can be written as 2 times ln 3, and you'll notice that this can be easily factored into t minus 2 times t minus ln 3. Therefore, we have t as 2 and ln 3, meaning that x squared, ln y equals either 2, ln 3 or ln 3, 2. Here, x squared must be positive. Since 2 and ln 3 are both positive, both values are valid. Therefore, x and y are given as, from the first one, we have plus minus square root of 2 and y equals 3, and from the second one, we have x equals plus minus square root of ln 3 and y equals e squared. For the second method, let us use the traditional approach of eliminating one variable first. Let us eliminate y first. We can actually do that in more than one way. For example, from equation 1, if we multiply e to the power of negative x squared on both sides, we have y equals 3 times e to the power of 2 minus x squared, and we can substitute this into y in equation 2. Or in equation 2, the value of y to the power of x squared is given, and we can use that value instead. In order to do that, equation 1 must also contain y to the power of x squared. So what we do here is to raise to the power of x squared on both sides of equation 1. So we have this raised to the power of x squared and this raised to the power of x squared. And if we carefully apply the exponent rule, we have y to the power of x squared times e to the power of x squared times x squared equals 3 to the power of x squared times e to the power of 2x squared. And now we substitute y to the power of x squared with equation 2, which gives 9 times e to the power of x to the power of 4 equals 3 to the power of x squared times e to the power of 2x squared. Here, using that 9 is equal to e to the power of ln 9 and 3 is equal to e to the power of ln 3, we have e to the power of ln 9 times e to the power of x to the power of 4 equals e to the power of ln 3 raised to the power of x squared times e to the power of 2x squared. So here ln 9 equals 2 ln 3. And for this part, we have e to the power of x squared ln 3. So we have e to the power of x to the power of 4 plus 2 ln 3 equals e to the power of x squared ln 3 plus 2x squared. So these two exponents are equal, which gives x to the power of 4 plus 2 ln 3 equals x squared ln 3 plus 2x squared, or x to the power of 4 minus 2 plus ln 3 x squared plus 2 ln 3 equals 0. This is a quadratic equation of x, but since it only contains x to the power of 4 and x squared, we can consider this as a quadratic equation of x squared. This can be factored into x squared minus 2 times x squared minus ln 3. So we have x squared equals 2 or ln 3. And using equation 2, we can obtain y. First, when x squared equals 2, that is, x equals plus minus square root of 2, then from equation 2, we have y squared equals 9. And I have already explained that y must be positive, so we have y equals 3. And when x squared equals ln 3, meaning that x equals plus minus square root of ln 3, then from equation 2, we have y to the power of ln 3 equals 9. So taking ln on both sides, we have ln 3 times ln 9 equals ln 9. So ln y equals ln 9 divided by ln 3, and ln 9 is equal to 2 ln 3, so this divided by ln 3, which gives 2, which gives y equals e squared. You can actually directly obtain this by raising this to the power of 1 over ln 3, which gives y equals 9 to the power of 1 over ln 3, and this 9 can be written as e to the power of ln 9. So we have e to the power of ln 9 over ln 3, so e to the power of 2 ln 3 divided by ln 3, so e squared. Anyway, combining these results, we have x, y as plus minus square root of 2, 3 and plus minus square root of ln 3, e squared. And I am still not done with this video. Now this is not a necessary process, but here I will directly substitute these values of x and y into the equations to check whether these roots are indeed valid. Let's deal with these two pairs at the same time, because they both give x squared, y as 2, 3, and we only have x squared and y here. Then you can easily notice that these values obviously satisfy these equations. So let's move on to these two pairs of roots, which give x squared, y equals ln 3, e squared. Then we have first y times e to the power of x squared equals e squared times e to the power of ln 3. And since e to the power of ln 3 equals 3, we have 3e squared. And y to the power of x squared gives e squared to the power of ln 3. So e to the power of 2 ln 3. So e to the power of ln 9, which equals 9. So every pair of roots that we obtained is valid. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons if you enjoyed this video, and I will see you in another video.